Good morning, everyone. Our group assignment is on the topic of limits. My lecturer for this topic is TS Dr. Gede. We have 4 group members. My name is Siti Nur Aisyah binti Muhammad Amir Bakir, and the second is Nurul Madeha binti Syabki. The third is Azmira Izani, and the lastly is Aina Elisha binti Zaidi. To give you a better understanding of how we approach solving limit calculation, let us take you through our step-by-step process and the strategy we use. Let's go. Assalamualaikum and good morning everyone, and my lecturer Segede. My name is Siti Nur Aisyah binti Muhammad Amir Bakir, nama matrik DB240152. Today I want to present about part A concept review. The first is about definition of a limit. What about definition of a limit? Okay. The first is a limit describe the value of function f open x close bracket approach as its input x gets arbitrarily close to a specific point C. It focuses on the behavior of the function near that point, not necessarily its actual value at the point. Limits help us analyze functions with gaps, jumps, or undefined values. They form the foundation of calculus, especially for derivative and continuity. That's all for me. Thank you.
One-side limits. A one-side limits consider a function behavior when the input approach number from only one direction, either from the left, x divide to a minus, or from the right, x divide to a plus. These limits are essential when studying functions with step change or difference definition on each side of a point. A two-side limit exists only both one-side limits exist and are equal.
My name is Aina Elisha binti Zaidi, number matric DB240064. Infinite limits. Number 3. An infinite limit occurs when the output of a function increases without bound, positive infinity, or decreases without bound, negative infinity, as the input approaches a specific number. Infinite limits typically appear near vertical asymptotes, indicating that the function grows extremely large in magnitude rather than settling at a finite value. 4. Limit laws. Limit laws are algebraic rules that allows limit to be evaluated by breaking a function into simpler components. They apply to sums, differences, products, quotients, and powers provided each component has a limit. These laws streamline calculation and enable us to evaluate complex limits efficiently and systematically.
The lastly is about squeeze theorem. The squeeze theorem states that if a function is trapped between two other functions that both approach the same limit, then the trapped function must approach that limit as well. This theorem is powerful for resolving limits involving oscillation or complicated expression, especially when direct substitution is impossible. That's all for me. Thank you. Okay, the part B is limit calculations. The step 1 is we are asked to find the limit of x squared minus 9 over x minus 3 as x approach 3. So, the step 2 is identify the issue. If we directly substitute x equal 3, the numerator becomes 3 squared minus 9 equals 0, and the denominator becomes 3 minus 3 equals 0. This gives an indeterminate from 0 over 0. So, we cannot substitute directly. The step 3 is factor the numerator. We factor x squared minus 9 using the difference of square formula. X squared minus 9 equal open parenthesis x minus 3 close parenthesis time open parenthesis x plus 3 close parenthesis. So the step 4, now we can cancel the common factor open parenthesis x minus 3 close parenthesis from the numerator and denominator. Open parenthesis x minus 3 close parenthesis time open parenthesis x plus 3 close parenthesis over x minus 3 equal x plus 3. The step 5, after simplification, we can safely substitute x equal 3. So, x plus 3 equal 3 plus 3 equals 6. Lastly, therefore, the limit as x approach 3 of x squared minus 9 over a minus 3 equals 6. Okay, the answer is 6. That's all for me. Thank you.
Question 2. Evaluate limit sin x divide x. From problem 2, we evaluate the limit as x approach 0 of sin x divide x. This is well-known standard limit in calculus. As x gets closer to 0, the sin x divide x approach 1. So the answer is simply 1.
Limit problem number 3. Evaluate the limit as x approaches infinity of the quantity 5x squared minus x plus 1 divided by 2x squared plus 7 divided by x squared open parenthesis 5 minus 1 over x plus 1 over x squared close parenthesis divided by open parenthesis 2 plus 7 over x squared close parenthesis. The limits equals 5 over 2. Limits problem number 4. The first one is evaluate the limit as x approaches 2 from the right of 1 over x minus 2. Next, as x approaches 2 from the right, the denominator tends to 0 from the positive side. Then, the expression goes to positive infinity. There is a vertical asymptote x equals 2. That's all for me. Thank you.
Question 5. Use the squeezer theorem to evaluate lim x square root sin 1 divide x. For the last problem, we need to evaluate the limit of x square root sin 1 divide x as x approach 0. We use the squeezer theorem. We know that sign is always between negative 1 and 1. So, by the squeezer theorem, the limits equals to 0.
Hi, my name is Azmira Isani binti Azmarif. Today, I would like to talk about real-world example with calculation. Okay, so about instantaneous speed. Instantaneous speed is a key concept in physics and is one of the most common real-life examples of how limits and differential calculus are applied. So the first one is how limits are involved in this situation. In physics, the average velocity of an object over a certain time interval is found by taking the change in the object position and dividing it by the change in time. But to determine the instantaneous speed, the object's velocity at a precise moment, the time interval must become extremely small, approaching 0. Since dividing by 0 is not possible, we rely on the idea of a limit. Instantaneous velocity is therefore defined as the limit of the average velocity as the time interval approaches 0. And the second one is about what the limit represents. The limit gives the exact rate at which the object position is changing at that particular moment, which is velocity. First, geometrically, this limit corresponds to the slope of the tangent line to the position time graph at that specific point. And second, about physically, it represents the instantaneous velocity of the object at that moment. And third one is example of a calculation using a limit. Okay, so the problem that we have is an object is dropped and its position in meters as a function of time in second is described by a position function. So first we need to find the instantaneous speed of the object at a given time. So the solution is we apply the limit definition of instantaneous speed. First, we substitute the given position function into the expression. And second, we insert it into the limit formula for velocity. Third, we simplify the numerator. And fourth, factor from the numerator. And last one is we evaluate the limit.